Hello, everybody, and welcome to Loud Nigel Network. We are about to start our this evening's presentation, and we have with us today Raj Indugala, who is an amazing technologist, an agile leader, and is very well known in the Washington D.C. area because he's helped a lot of organizations and individuals achieve more in their organizations by integrating different practices. And he's brought to us today how to integrate AI into test-driven practices. So if you are if you are like me, who's very curious to learn more about how AI can help your organization achieve more, please help me in welcoming our speaker for this evening, Raj. Raj, over to you.
All right. Thank you so much for that kind introduction, Toby. Really appreciate it. Thank you all for making the time to be here. This is a new adventure for all of us, and I may not have definitive answers for everything here, but I think what I'm super excited about presenting this topic. It's a new topic, new journey, like I said, for all of us. My background is software development. I'm particularly passionate about agile engineering practices. And when I start to see the emergence of AI, as we all have, and trying to see where it fits into some of the topics that are of particular interest to me, I thought this would be a great opportunity for me to sort of talk about how we might integrate AI into some of our software engineering practices. Specifically, I'm going to focus around test-driven practices in this session. So my name is Raj, and a very brief introduction. I'm in the Metro DC area. I'm the principal consultant and SVP at Lightspeed. We are a boutique agile training consulting and transformation organization. Super excited to be here. The agenda for today's session, at a high level, we'll just talk about one specific AI tool, GitHub Copilot. And as I'd mentioned, this is an exploration of how we might leverage AI tools such as GitHub Copilot to enhance our software engineering practices, agile software engineering practices. Specifically, I'm going to focus on what it means to be test-driven with AI. I'm going to focus on two popular test-driven practices, test-driven development, of course, TDD, and then BDD, which is behavior-driven development, which are both test-driven practices. And then also sort of temper the whole hubris about what's possible with some cautionary tales, as well as some things to keep in mind as your teams, and your organizations are grappling with how might we leverage this new and exciting and yet unknown technology. So that's really the outline for this evening's conversation. Okay. All right. So generally, I like to keep it pretty conversational. And Toby, I will ask you. I don't know whether, given the small, the intimate setting, is it possible for us to have a conversation as we go through?
Absolutely. Everybody's welcome to unmute themselves and speak.
Yeah.
If somebody misbehaves, I will mute them.
And I'm also trying a couple of things. Not only is a topic a new topic for me, I've been playing with this for a little while now, but I'm bringing it all together here. But also, what's a technically oriented presentation. I'm not going to go deep into technical practices. I know the makeup of this group, but I think it is sufficiently high level, but it touches upon some technical aspects. Instead of hands-on coding, I've recorded some things to sort of demonstrate how you might pair with GitHub Copilot to demonstrate the topics I'm going to talk about. And hopefully that resonates with the group. Okay, so we'll keep it conversational. There's a little bit of demo, and I'll make sure that I'm sort of stopping at appropriate points just to make sure that we're having a two-way conversation. Okay. All right. So given this sort of broad outline, let's sort of get into Before we talk about what it means to be test-driven, maybe most of you are Agilis. This is the LAN forum. So I'm sure most of you have experienced in some manner what it means to be test driven. But before we get into that, a quick introduction about the specific tool that we are going to be talking about in this session, which is GitHub Copilot. So let's start with that. And I'm going to right away ask the question, how many of you have heard of GitHub Copilot? Show of hands, shout out the answers. Justin, go ahead. What is GitHub Copilot? Just, you want to share your thoughts?
It's an integrated LLM into your IDE.
Yeah.
So you have plugins in Visual Studio Code, IntelliJ, all the JetBrains products, and I think you can even get it for like Vim and Emacs too, but I'm not quite
You
sure.
can okay, fantastic. That's it. So Justin mentioned that it's essentially it is your coding assistant that's embedded into your popular IDEs. And if you're a developer, it can be an invaluable assistant in navigating the coding and the testing space. Specifically, like I said, we're going to look at test-driven practices. But that's GitHub Copilot in a nutshell. So thank you, Justin. So as Justin mentioned, what is GitHub Copilot? Think of it as your AI pair programmer. For those of you who are familiar with pair programming and all of those XP practices, it very much feels like that, right? It's an AI-powered coding assistant. It assists developers by suggesting code snippets, test cases, test scenarios, and it can autofill things based on context. And it all depends on the kinds of prompts you give it, much like if you're using ChatGPT, Gemini, whatnot. Prompt crafting is an important aspect when you're trying to work with GitHub Copilot, much like some of your other AI tools, no different here, right? And as Justin mentioned, it is this Copilot is easily integrates with popular integrated development environments or IDEs that your software teams must be using, like Microsoft Visual Studio Code, the JetBrains suite of products, and so forth, right? As I mentioned, what it can do for you right off the bat, let me mention this. It can suggest code snippets based on the context that you provide. We'll talk about what does it really mean, what does context mean, and such. I think these are the building blocks that we all need to be familiar with if you want to explore this this technology. It can autocomplete, suggest whole blocks of code, whole functions, can generate unit tests, can generate your functional test scenarios. It can you can point it to code and it can generate documentation for you. Essentially, what it can do for you is understand the context and enhance your coding efficiency. It automates some of the repetitive stuff. But again, as with any new technology, as I mentioned, there are cautions that I'm going to allude to later on. But in general, these are the kinds of things GitHub Copilot can do for you. And we'll obviously see this in action, but I just want to throw out some numbers. There was a 6-month study done by Accenture, and I think the results just came out, and I think I'll share this deck, of course. And there's some links here, both as we go through the material and in the appendix that you might find useful for yourselves, or if you want to share it with your teams. But anyway, so Accenture did a study, a 6-month study on the analyzing how good is this GitHub Copilot? Is this something that we could leverage as an organization? So it was a 6-month study of 450 developers, and I'll talk about what these numbers mean. But the overarching theme, as you sort of look at these numbers, at least to me, are two things: improved developer satisfaction, right? 90% of the developers found that they were more sort of satisfied with their job when leveraging GitHub Copilot. And I think 95% said they actually enjoyed coding more with this AI pair programmer. So improved developer satisfaction is one thing that emerges. And the second thing is also the ease of adoption, right? over 80% of these Accenture participants adopted GitHub Copilot with a success rate of about 96%. I think almost 50% said that they found it extremely easy to use. Within a day, they were up and running, right? There's a learning curve, but it's not a steep learning curve, right? As I'll demonstrate in a little bit. So to me, those are really important things that emerge from this study, is that improved developer satisfaction and the ease of adoption, right? Given that broad statement, I just want to quickly touch upon some of the findings from this study. I'm going to start with the far left. When they say activity, what they're talking about is what percentage of the code or lines of code or tests that were generated by the AI pair programmer, GitHub Copilot in this case, what percentage was accepted into their code base, and it's 35%, right? And the number below, and of that 35% of code that was integrated or accepted into their code base, almost 90% of the code was retained, which is a pretty substantial number if you think about it, right? So that's the activity number. When you look at productivity, now this is also interesting in these days of DevOps and continuous delivery. I want code to be close to mainline trunk-based development. You hear all these terms over the years, and what this shows in the productivity number is 50% more pull requests, which basically means, for those of you who are more closer to the development realm, a PR essentially means that code is being merged into a common branch, mainline or trunk. 50% more pull requests as a result of using GitHub Copilot, and a higher merge rate, which is what that's showing. So clearly indicating a higher level of productivity. And the next, the column talks about efficiency. If you have more PRs, there's also more builds, 50% more builds that are happening. And the number below that, 45%, is higher success rate. What that means is, if those of you are familiar with the DORA metrics change failure rate, it's not just blindly triggering a build and builds failing. The actual success rate of those builds was also up, right? So when you look at this is pretty darn impressive, right? Based on the study. As with most studies, I'm old enough, and I mean, I take it all with a pinch of salt, but still, it is pretty impressive as to what GitHub Copilot or some other AI tools such as this can do for you and your organizations and your team members as well, right? So keep this in mind as we go through the core essence of our topic, which is about how might I leverage this for driving my test-driven practices. Okay. All right. So if there's any questions, or just shout out. But I think I just want to get to the meat of this very quickly. But I wanted to just mention some data around these new emerging tools. All right. So the question is, this all sounds wonderful. It's a AI pair programmer, a coding assistant, auto-completes code for you. All sounds wonderful, but how does it really work, right? And I think it's important to understand at the highest level, without geeking out here, as to how this works, because it helps us exploit the tool that much better, right? So the three characters at play are us, the humans, the developers, the team members, working in an integrated development environment or code editor, right? And then there is the GitHub Copilot extension to your editor that is essentially going to take your prompts and the context and do something meaningful for you. And then there's actually the LLM, the Open AI Codex, because ultimately what you'll see in a second, what happens is, as individuals, developers, team members, within your code editor, you are crafting intelligent prompts and say, I'm stuck with this. Oh, can you think about some unit tests? Can you help fix this code? Can you help explain the code? Can you document the code? All of these are commands that a GitHub Copilot allows for you within your IDE as prompts. taking the prompt and then something called the context. And I'll talk about what context means. What GitHub Copilot does is takes your prompt, looks at the environment in which the prompting is a prompt is being asked, which is the context, and then essentially yes, sends that to the OpenAI codex, and the OpenAI essentially then looks at all of the open source code in the GitHub repos worldwide and collects the data and sends the responses back in the form of suggestions to the developer within the IDE, and then you can take the suggestions as is, discard them, take part of it, edit it, make it your own, right? So in a nutshell, this is how GitHub Copilot works, right? It's the intermediary between you, your editor, and the OpenAI body of knowledge, if you will, or the LLMs, right? So I think understanding this level of detail is more than enough as you sort of navigate to the next step, right? And I know there's always fear, is the data going to be secure or not? From what I understand, and again, like I said, I'm no expert at this. I'm just an enthusiast who happens to be playing with this and find this very, very fascinating. The data is all deleted. It's just not going to be saved for something else, right? So for some devious purposes, at least that's the claim, right? So so in a nutshell, these are the three players, and these are the essential elements, right? Code editor, through which the GitHub Copilot is an extension. And by the way, it's freely available. Actually, GitHub Copilot is available 30 days for free, and after that, it's a nominal fee. I think it's $9 or something like that for an individual license. So it's not quite free, but you can play with it for a month for free, right? So, and as I mentioned, when I share the deck, the reference in the appendix, there's instructions on how you how you could set this up, where to get it. All that information is there. I'm not going to walk through that. It's there for your reference. Okay. All right. So now that we understand at a high level how this stuff works, a couple of things for us to be cognizant about. Just like when you're using, as a Chat GPT or your favorite AI tool, prompt crafting is super important, right? The flexibility of AI could also be I won't say its downfall, could be something that could cause us to be completely confused and go off in the wrong direction, right? So when we talk about providing that prompt to GitHub Copilot, three things we want to keep in mind, right? Be very clear about the goal, right? I'm showing some sort of everyday examples. You cannot be vague because it's just going to make up stuff, right? Because you have to be very clear. I want this specific thing. This is the reason I want it. Be very clear in the intent. Be also very specific. Sometimes giving examples could be very helpful in its suggestions for code snippet and tests and such. And we'll see this in action a little bit in this session when I do the demonstration, right? So nothing new here for most of you, but the same rules apply, right? Intent, clarity, and specificity are king, especially if we can give concrete examples. It's all that much better in terms of the quality of the answers and suggestions you're going to get back. The second thing is as important, which is I talked about in the earlier slide. From your IDE, you have the prompt, but there's also context you need to give, provide GitHub Copilot. What we mean by that is it's not just dumping your entire project space into the LLM and saying, hey, find the appropriate suggestion. No, what it's doing is it's looking at the proximity of the prompt where you're entering it. Which Java file are you working? I'm just showing Java, Python, whatever language that you're working with. It looks at the current file first, and then it looks at its adjacency. What other related tabs are open? So it behooves us as users of this to make sure we provide that context or that environment when you're suggesting the prompt, right? Then your answers are going to be that much richer, right? Otherwise, it's going to be completely, I won't say random, but it's difficult to narrow down the scope of the suggestions if you don't keep the prompts crystal clear, and also establish that context, right? The current file you're working on, and open up all the related tabs. That way it knows. So that's the piece it's going to send up to the OpenAI Codex to find the answers. It's not just uploading the entire project, right? So anyway, when I first started playing with that, I thought, oh, it's just taking the entire project and doing something. No, that's not how it works, okay? All right, so with that in mind, I think that's just, yeah, go ahead, Justin.
In the Copilot chat, you can hit like at least on a Mac, Command Enter, and it will search the whole workspace, or you can do an at workspace annotation,
Yes,
and it will scan for relevant things.
Yeah, absolutely right. And Justin's right. For those of you who've played with you probably know what Justin's talking about. In this session, we're not really going to go through all of those things. There's a lot of stuff, but just enough to get you excited and start the journey if you haven't already, right? So I'm going to now pivot very quickly and talk about now that we know the basics. Let's talk about how we might apply this to test-driven practices, and then we'll start to showcase the capabilities of Copilot. This session is not going to be a session on test-driven practices as much as I love TDD, BDD. That's not what this is going to be about. But I want to establish the context, right? So what does it mean to be test-driven? Anybody? What does that mean? Whether you're developers or not, you've been in the agile space, you've probably heard this term ad nauseum, you're sick of it. What does it mean to be test-driven? And why should we care?
Test drive the architecture of your code.
Test drive. You're using test drive and test-driven, but yeah, generally, right? You're using test to guide the design and development and the testing of your code. Okay. Anybody else as to why should we care? How is that different than what does not test-driven mean then?
Well, so the benefits really to the test-driven development is that you're building incrementally functionality that is working on the functionality that's on top of working functionality. So you don't end up with one big bucket at the end that you've got to untangle and test all these different scenarios from scratch and from the beginning. And if you build that into the code and the tests into the code, then the code can do a lot of the test work for you for regression tests.
Yeah, so fewer regressions. Yeah, just to summarize, thank you for that answer. Yeah, so essentially, fewer regressions means reduced defects and generally higher quality software, right? So that's what test-driven practices give you, right? So very, very quickly at the highest level, when we talk about test-driven, the genesis for all of this was extreme programming in the late 90s, early 2000s, when Ken Beck codified the term test-driven development in his book, Extreme Programming. And that's the stuff you do in the far right, essentially where you're using unit tests and incrementally writing a test, writing some code, writing another test, writing some code, making sure you're building the right thing. That was the genesis of what it meant to be test-driven in the context of using unit tests to drive the design and development of your units of code. That's TDD, or test-driven development. Now, a few years later, in 2006, building upon the idea of TDD. TDD, by the way, is essentially a developer activity. But building on the concept of TDD in 2006, behavior-driven development, and then acceptance test-driven development, all of these sort of slight variations on that central idea emerged, where instead of focusing on those micro units of work, why not we take this idea and apply it to the overall system behavior from a user's perspective. And that essentially sort of gave rise to BDD, where you're starting to think about, am I even building the right thing? Not just about, am I building the thing right, but am I really building the right things? And this really became about requirements elicitation. It became about conversation and creating a shared understanding among not just developers, but developers, testers, analysts, your business stakeholders and such. So that's another nuance. But regardless, all of these practices are about improving the quality, reducing your defects, and such. So given this basic understanding of what it means to be test-driven, so let's look at how we could use AI to assist with our BDD practices. So as I mentioned, going back to the previous picture, the picture on the right, building the thing right, that's TDD. That's a very developer-centric activity, right? Building the thing right. Whereas BDD is really the outside-in piece. Am I even building the right thing? Am I thinking about these stories and features appropriately and such? So that's where we're going to start, and then quickly go into how you're going to apply AI to TDD. But first, we're going to start with how might we boost our BDD practice with AI. So in order to look at that, first we need to understand the basic workings of BDD process, right? BDD process ultimately is a four-step process. It's quite simple, right? You have conversations among the different stakeholders or roles, right? Developers, testers, analysts, product owners, what have you, before you start writing the code, right? That's the discover piece, where you're thinking about the features, stories, thinking about the boundaries for these features and stories, the acceptance criteria, if you will. And the second part of the BDD process is, once you've had the conversation, is capture those conversations in so that you can drive the design and development, right? So this is the formulation a piece of it. In the formulation piece, you're essentially capturing the conversation in some common language that's easily understood by developers and non-developers. And the format that's emerged as the most popular one recently is the Gherkin format, and which perhaps most of you are familiar with, right? The given, when, then, feature file, scenarios, and such, right? So this is a codification and an elaboration of the acceptance criteria into concrete scenarios captured in your Gherkin feature files. Now, which in turn can be used to automate not just those specifications, it can drive your coding effort, your unit testing effort, as well as your functional automation, right? All of that can happen, and this virtuous cycle continues. So this, in a nutshell, is the BDD process. As you can see, the conversations are the starting point. Formulation into that common language is an essential part. Now, whether you actually use Cucumber, Karate, whatever, is really not the most important part. It's 1 and 2 are the most essential parts, if you ask me about the BDD process. So again, it's all about bridging the gap between technical and non-technical people. And as I mentioned, Gherkin is one way of expressing those boundaries for those features and stories, which can then subsequently be used for automation. Now, how many of you are familiar with Gherkin features and given, when, then syntax? Anybody who's not familiar? Everybody's familiar with it? At the highest level, right? Yes? Yeah. All right, since I don't see any hands that say no, I'm going to skip this. I'm going to assume you understand the basic feature files and what a scenario is. Think of a scenario as a specific test case. So now most of our teams use these Gherkin scenarios to express their acceptance criteria and such. Now, before we look at how Copilot can help us with this, if I had asked you, take a look at this, right? Let's assume we just have a simple feature we're building. It's a bank account management feature of some sort. And a bank account management feature would have things like deposit into account, withdraw, transfer, pay bills, what have you, right? So before I demonstrate how we could use Copilot to assist with the imagining of the scenarios and capturing them, let me ask you this. When you look at deposit, for example, if deposit into account is a story, what are some of the test cases that you could come up with? Right? Looking at your own Wells Fargo usage of how you use your account. What are some things that you might want to think about? If you're building a story, depositing money into a simple bank account. Anybody? What are some test cases that come to mind?
Is it going into my account?
Okay, so
And
that's
is the
assuming
right
there's a
money?
single account. Yeah, is it going to my account? Yeah. What else? Just throw out some simple cases.
Confirmation that the money's there.
Yeah, check my balance. I put $100. I better make sure that my balance is $100. What else? What else?
Maybe not depositing negative amounts.
Yeah, maybe not negative. Think about the boundary conditions, right? When you think about test cases, you're really thinking about not just the happy path, but the boundary conditions. What about negative values? What about zero? What about something else, right? So all kinds of things start to open up when you're thinking about acceptance criteria and test scenarios. So given that context, so let me quickly show you. And I'm going to sort of end this presentation and open up a recording of what I want to show here for a second. Let's see. Oops. So in this demo, we'll see how GitHub Copilot can help us with envisioning and formulating these test scenarios, right? I'm going to stop share. I'm going to open up another share. All right, so I'm going to open up. And I apologize in advance. I think there's a bar at the bottom that I can't really get rid of. As I mentioned, it's a new journey, trying different things. And this is unfortunately one of a failed experiment. But anyway, so this is Microsoft Visual Studio Code, an IDE, and I've already integrated GitHub Copilot in it. And I'm showing a simple feature file. I know it's a little hard to see, and I apologize, but for demonstration purposes, I'm going to quickly play it. So what I want to do is to go back to what we talked about, deposit and such, and come up with scenarios for deposits and withdrawal and see how GitHub Copilot can help us, right? I'm going to play this. So I'm quickly showing you how to launch GitHub Copilot. On the far left, the left-hand side is my AI assistant, GitHub Copilot. And I'm typing some things here, and you can't see it here. What I'm saying is, for my bank account, can you suggest some scenarios for the deposit capability, right? So I'm interrogating my partner, which is GitHub Copilot. This is the left-hand side. I submit that, and lo and behold, right? My pairing partner says, yeah, here are all the different kinds of scenarios you can think about. Deposit to a zero account, try depositing a negative amount. How about depositing multiple currencies? Should we be able to deposit to a closed account? What's the maximum deposit that you could that you should be able to do in a day? All kinds of reasonable suggestions, given the prompt that I gave it, which is, hey, just give me some scenarios for depositing money into account. Now I said, that's great, but now can you express these in the Gherkin syntax? And it says, not a problem, right? And for all of those various scenarios that it suggested, it's spitting out the Gherkin scenarios. And now I'm going to be the human in this, and I'm going to say, you know what? These are great, but I'm only going to take a couple of them. I'm going to deposit into a positive account. Maybe that's, for now, that's good enough. And I'm going to get the scenario for negative amount. I'm not interested in other currencies and so forth, right? That's fine. You pick and choose what you want. And also, if you look at this, the last one, depositing a negative amount, I know it's hard to see. It spit out a generic scenario, but I want to customize it. I want to essentially say, I not only want you to not allow depositing an account, I want to see an error message that says this is an invalid amount. Please enter an amount greater than zero. You can absolutely do that. So if for those of you, if you've ever done pair programming, this is essentially the rhythm that you would follow if you have sitting with somebody beside you. They're suggesting things, you take some ideas, you incorporate both ideas, you make edits. That's precisely what I am doing here with GitHub Copilot to sort of envision and come up with these test cases for this feature or story that I've yet to build, right? That's the part of it, right? I'm trying to define the boundaries for this deposit capability, right? Now, then I'm asking, how about some withdraw scenarios for withdraw? And it gives me a whole bunch of scenarios for withdraw, and they're all very, very reasonable, right? Happy path when there's sufficient balance. When there's insufficient balance, it's saying it won't allow it. It's helping me think about things that perhaps I might not think about, right? That's essentially what it's really good at, right? But ultimately, as I mentioned, I have to be the human in the loop, right? Too often, I think, I know my kids do this same thing and say, oh, I let this Copilot do the assignment for me. It's not going to really work very well if you have that attitude, right? So you have to be the human in the loop. Anyway, so just a quick demonstration of the kinds of things you could do in terms of using Copilot to envision, dream up scenarios, take them, refine them, and essentially clarify these stories before you start to build out the capability, right? So I'm going to pause here. I'm going to go back to the presentation, and I want to take this next step, which is to see how I could use this to turn this into actual a unit test, right? So I've taken the liberty of not demonstrating to you, functional test automation. Here I'm using BDD just to ideate on the scenarios, express them in Gherkin syntax, and that's it, right? So I'm not demonstrating the third step, which is functional test automation, which it can do, right? But what I want to do is show you how, once I have these stories that are clarified with this very clear acceptance criteria, how I could sort of jump in to the test-driven development rhythm and use this to guide my TDD practice, okay? All right, I'm going to switch back. All right, so we looked at how we might brainstorm test cases, acceptance criteria, and formulate those very crisp, testable examples in the form of given, when, then. Now let's look at how we might test drive the design and development of that said functionality using a GitHub Copilot, right? So this is, we're going to drop into the TD practice. So in a nutshell, test-driven development, the way it was first sort of envisioned by Kent Beck, like I said, late 90s, early 2000s, as part of XP, is instead of writing unit tests at the tail end, once you finish writing out all the code, you write, you define the intent of what it is that you want the code to do. You write one test, you watch the test fail, then you write the code to make the test pass, and then you come back and clean up the code with the protection of that test, and that cycle continues. So this is this fast-paced, what they call the red-green refactor rhythm. An agile developer who practices TDD, this is the rhythm that they follow, right? So writing unit tests and writing code become one seamless contiguous activity. It's not something that's done after the fact. Oh, if I have some time, oh, I need to meet some code coverage report, so I'm going to bang out some test cases. So that's really a test after approach. So test-driven development is really about that incremental building up of unit tests and incremental building up of code to make that test pass. So it's that the continuous back and forth conversation between a unit test and your code, right? So that's TDD in a nutshell. So let me demonstrate to you how you could use GitHub Copilot to test drive this deposit capability, for which we've envisioned some scenarios, okay? So I'm going to stop my presentation here, go back to let me share my, where is the other one? Give me a moment, please. Oops. Where is my demo? I told you this Loom integration was a little bit of a tricky thing. I'm not sure. Are you seeing anything? What are you seeing right now, folks?
We're seeing you.
Just the screen.
Yes, that right. You're not seeing that. Let me.
Just the participants.
I want to see. Give me
And
1 second. I'll get
The
that.
other share worked fine.
Yeah, the other one worked, and I need the BDD one. 1 second.
Hey guys, while we are waiting, if you have any questions, please put it in chat, and we are going to facilitate those towards the end. So you can take this time to put any questions that you might have in chat, please.
Right. So let me just. I think I found this. Give me a. Where is Zoom? All right. I think I found it. All right. We're going to share that. Oh, not that one. What are you guys seeing now? Oh,
It
A
just
message.
blank.
Yeah, a message indicating that your starting screen share, but that's it.
never fails. Where is it? Ah, found it. There you go. Do you see my screen now?
Yes.
Yes.
All right. Okay. Okay. So this is going to be a demonstration of the TDD rhythm that we spoke about. So at the outset, what you see on the screen is just that feature file we worked on, where with the assistance of GitHub Copilot, we created some test cases or scenarios, right? So I'm going to focus on how we could use this to drive the creation of the deposit capability, okay? So note that I don't have a deposit Java function. I'm using Java here. I don't have any test cases or anything. I just have this test scenario expressed as this Gherkin scenario. That's all I have as my starting point. Now let's see how I work with GitHub Copilot to make this all sing and dance. All right, so I'm going to play them. So what I'm going to do is right now I open up a test class, and you notice I'm typing in test because I'm test-driven developer. So I'm going to first say, hey, I want to basically write a unit test to deposit $50, right? That's one of the scenarios we come up with. Deposit $50 and check the balance. As somebody said, that's the simplest thing I want to do. I just wrote a comment such as that, and right off the bat, GitHub Copilot gives me the unit test case. And I look at it and say, oh, that looks good. This test deposit $50, but there's a compilation error because deposit function doesn't exist. But I use code completion, and essentially GitHub Copilot tells me in order for that test to pass, all you got to do is that little snippet of code. I run my test now. So it helped me create the test. It helped me create the code snippet to make that pass. And not pass yet. It just created the deposit, but it says right now, if I pause it, it says that the test failed because all it's done in the past is created the deposit method. We didn't really actually write any code to make it happen. Remember, you write a test, watch it fail, then write code to make it pass, right? That's the TDD rhythm. The reason you want to write a test and watch it fail is because that way you know that the capability that you want doesn't exist. So the act of watching it fail is to prove to yourself that, yep, that capability is not there. And then you go write code to make it pass, okay? So I'm gonna play it now. All right, the test failed. And now I say, I know I need to make this test pass. So I go back into the production code, and as I'm typing in the logic, my assistant is already filling out stuff for me, and what it suggested was good. So I take the suggestion, and I come back, I run the test, and guess what? It passed the test, right? Now I come back and say, you know what? I'm highlighting the code. and I go to my prompt, which you can't see at the bottom left, and say, hey, what is the simplest improvement you can make to refactor this code, is what I'm asking it, right? In this case, for demonstration purposes, this code is pretty simple, but still, I wanted to test it out. How might I improve it, right? As soon as I do that and hit enter, it gives me some suggestions. You know what? The name that you're using, it could be improved. I say, yep, I like that. And I take the suggestion, and now this is more readable code, right? And then I run my tests again, make sure that the refactoring did not break anything, and nothing's broken. All my tests are still passing. This is the basic TDD rhythm that essentially I am conversing with GitHub Copilot to help me do these things, right? The other thing I'm going to demonstrate here is you can just select a function and say, generate unit tests for me, and it'll generate all kinds of tests for you. Again, you're not beholden to take all of them, but at least it's helping you expand and clarify your thinking. On the far left side are all the suggestions for unit tests, and I'll take the ones that make sense to me based on the scenarios that I had developed along with my testers and such. And there you go. What is the next thing I'm going to do? So all I wanted to show here is, I know it's a little choppy with the video, but hopefully I was able to demonstrate to you how the TDD rhythm can be implemented quite nicely using GitHub Copilot. It can also generate documentation for me that I can take. All kinds of things that are generally repetitive in nature, GitHub Copilot is quite good at in alleviating that, the tiresome repetitive work. Right? So as I switch back to the presentation mode, I know we're almost at time here. I just don't want to spend too much time and leave time for questions. Any questions for you as we looked at these two use cases, how to use GitHub Copilot for formulating those Gherkin scenarios, how to use it for driving your unit tests and code? Has anybody used it in this manner? Justin, yeah? What's your experience? Why don't you share your experience?
Yeah, I use it most days. I actually prefer, like when I'm doing local development, there's something called Cursor SH, which is kind of like it's a whole IDE built around AI, but it has many Copilot type things. Yeah, getting the edge cases, trying to figure out how to test something like today I was using it at the bank client I'm at, and I was writing Angular tests using testing library and Jest and some other things. So very familiar with the React ecosystem. Going over to Angular, it tells, like, that's one thing that I really like about it too. It's like I know exactly how I want to TDD this, but I don't know how to do it in this particular framework, tool set, or whatever.
Yeah, that's another great use case we didn't touch upon. Learning new skills, right? New languages. It's great as a teacher, right? So in this demonstration, I mean, we used Copilot as a partner, as a colleague, but there's a use case for using Copilot as a teacher, as a coach, as a mentor, right? So anybody else, your examples or anything that you're familiar with in terms of using GitHub Copilot in this manner or some other manner? Anybody else? So as exciting as all of this is, even in that very rudimentary example, and obviously, right, because the use case that I gave it, bank account, Java class, it's pretty ubiquitous. Its suggestions are phenomenal, right? It's not going to be so great when you're trying to apply that in the context of your specific environment, and that's where you need to build the LLM with the codex so that it can give you those kinds of suggestions. But you'd be surprised as to how good it is and how quickly and how quickly things are getting better. But as exciting as all of those earlier studies are, here is a cautionary tale, right? And again, the links to the detailed articles are here. There's a new term that emerges called code churn, right? What code churn means is essentially the percentage of code being reverted or being updated within two weeks of it being ingested, right? So with the proliferation of AI tools and tools such as Copilot to auto-generate code, more and more teams are using the suggestions, but perhaps we are taking the suggestions too blindly without enough due diligence, because mistakes are getting into production at an alarming rate, right? So that's the cautionary side to this tale, so to speak. Code churn is increasing, and it is set to double from 2021-22 levels to double by 2024, right? That's an alarming increase in terms of mistakes getting into production only to be reverted later on. Why do you think that might be happening, right? What do you think some of the possible causes of code churn are? Anybody? Why? Anyone?
Too much trust.
Too much
Right.
trust. You're not being the human in the loop. You have to, if you're just going to cut and paste code just because it suggested it, guess what? You're going to be in trouble, right? You have to be the human in the loop. Leverage it, but don't blindly take suggestions. Copy and paste code accounts for a large percentage of code churn. People are not refactoring the code. It's a suggestion. Take it, make it your own. You're not refactoring it as much, right? If you don't think about it intentionally, mistakes are going to happen, and code churn is going to proliferate, right? So that's the cautionary tale. So as cool as these tools are, as we close this presentation, to implement AI tools effectively, especially the development AI tools, the one we looked at today, yes, you do need technical skills, right? You need to be good at prompt crafting, but you must be good at prompt crafting anyway, even if you're not using GitHub Copilot. You need to double down on your code reviews. Don't blindly take code. That's a recipe for disaster, right? Automate more, automate your testing more. You have the tools at hand, but again, verify that the edge cases are pertinent to your context. Make sure that the test coverage is comprehensive. That tool can help you. But in addition to that, you need soft skills as well. You still have to be able to solve problems critically. You need to be flexible, because if you're not adaptable, then that's a recipe for disaster, because AI tools, you want to play with these kinds of tools. Be cautious, maintain that growth mindset, be flexible, embrace these tools. They're only getting better. But note that in the end, your communication skills, your problem solving skills, your desire to build the right solutions for your customers, that empathy, those are the soft skills you still have to retain and amplify, right? So at least that's just my 2 cents on that. Last 3 takeaways, and we can have a few minutes for questions. I say always invite AI to the table, right? When as a developer, especially in the context of this, you're a developer, test automation engineer, analyst, always invite AI to the table, but always be the human in the loop. Don't take things blindly, right? And I think that's the risk. And also assume that this is the worst version of the tool that you're currently using. Things are getting so good, so fast. Yeah, so I recorded this last week. I'm sure there's new features there that I don't even know about, that Justin's probably going to tell me tomorrow, right? It's assume it's the worst version that you'll ever use, right? These are the key takeaways from me to you, right? So, and in the end, like I said, this talk was about moving from test last to a test-driven paradigm with your AI pair programmer, and you can use it for both building the right thing, the TDD level, as well as that BDD, are we building the right thing, right? So, and that's really it. And thank you all for participating, and thank you, Toby, Meenakshi, and the LAN team for inviting me to speak.
Excellent presentation. I think so much was shared so fast, and I was like just wowed by looking at how awesomely the tool generated those things. And you shared great insights to be careful, bring your human touch to it, and you be the judge. So I think there's so much that everybody has learned. So a couple of questions, just two so far. So one is from Justin, and he asked, how can I make this code more clean?
Ah, okay.
No, that wasn't a question. That's normally what I like to ask
Oh,
ChatGPT.
Yeah.
I see.
So
Okay.
like you
That was
would
a
take like
prompt.
your
That's a prompt. Yeah.
Oh,
yeah, you would take your whole thing and then
okay.
it'll
Sorry.
say it'll do things like Raj was doing, but it's a more
Got
macro
it.
level. I like the idea of saying, hey, what is one simple thing? That was
Got
cool.
it. Sorry, I'm not as smart as AI. I misunderstood the question. All right. So there's another question, and that's from this guy called Toby, and he says, how does AI testing tools such as the ones you demoed integrate with the traditional automation tools that my org may have already invested in?
So I mean, at this juncture, that's a fair question, and I'll be very candid. I don't know how it works with some of the other tools that are outside, like Load Runner, or I don't know what
Yeah.
other tools are. But I think the mainstream, at least in a lot of the clients I work with, the tools that we use for both unit level testing and functional automation are really the tools that a Copilot can already work with quite nicely. There should not be any issue.
Okay.
There are going to be certain things that it won't work with, but at least think about it, right? I used it for only idea generation of scenarios, not necessarily to automate those functional tests, right? So as you know, Toby, most of the problem we see in a lot of the Agile adoptions is lack of clarity and shared understanding of the boundaries of features and stories. You could use it just for that piece, right?
Right. Absolutely. And I think it works wonderfully.
Yeah.
Excellent. Any other questions? Feel free to open your mic and speak.
Toby, even with that previous question that you just asked, if you were just using vanilla Chat GPT and as like a QA professional, you're like, what are given this criteria, and you paste like, as long as your organization allows you to do that, you paste it into an LLM and say, what are some edge cases? What are things? Could you write test cases for this? Could you, how would I automate this and things of that nature?
Right.
That's why I said it have to understand your current tools, what you're using, and then what constraints. Because I work at like a bank right now where they don't allow Chat GPT, but I'm allowed to have Copilot. So,
Okay.
which is weird because I found a way to jailbreak Copilot. Yeah, so I jailbreak Copilot and I use it like an LLM throughout the day. I
Oh, yeah.
summarize emails.
Yeah.
Like there's some things you can do to it. I write
Absolutely.
a definition of the day for alternative investments, and people think I'm smart, but I'm just like feeding a term into Copilot.
But this is interesting. I think Justin's observation is cool because I think at least two of the clients I'm at, they will not allow ChatGPT, but they are full steam ahead to integrate GitHub Copilot because they want to improve developer productivity.
Yeah.
And save costs. Absolutely.
I have a question for Justin, if I may. Justin, have you experimented with the ChatGPT and Copilot, and which one would give you, is there any difference in the code? I don't understand the context, but maybe different because you don't have enough context there.
Yeah.
I don't like copying, pasting from code to ChatGPT and back to ChatGPT to code. So I really prefer something that is integrated in it. Like Copilot is fantastic for that. And it seems like the results from Copilot are better than just vanilla ChatGPT most of the time. But that's I mean, I normally write in languages like Java and Python and TypeScript. So I mean, most common languages, either one's gonna get is gonna knock it out of the park.
Yeah. So Manoj, if I may add, so right now in one place we are doing a lot of infrastructure as code work, and that's where this is not so good, right? For mainstream programming, this is great. I use actually Gemini for some of those more esoteric questions around scripting and things like that.
Oh, I see. Thank you.
Yeah, I think
helpful,
that
folks. I know there's a lot of information. Next time I'll probably shorten it or something. Was this helpful?
Yeah, definitely.
Yeah.
So what I suggest is if people are curious, and Raj, if you're willing to stay a couple of more minutes, we could hang out after that. But I would
Yeah.
like to invite Meenakshi to do the official closing. And if you're okay with that, we can hang out and have some more questions, and
I'm
I'll
okay with that.
turn video
Thank you
off
all.
at
Thank
that
you all
point.
for showing up, and thank you, Alan. So.
Yeah, thank you, Raj. This was exciting I see a lot of people who don't do this for a living also being excited about this topic, and that's kind of a sign of a true teacher, a true guru, who can make it exciting not only to people who are directly related to it, but who would not typically feel passionate about the topic. So thank you. All right, next month, join us, Loud and Agile Network folks, for AI and Agile Better Together. And we have Snehal Talati coming to present this, and come and find out more. So sign up. The link is in the chat. Toby already added that. I would go ahead and add it again. And we look forward to seeing you all then. Thank you.
Thank you all.
Thank you.
Yeah. If